Live from San Diego, this is the Fox 5 News at 4.
On this Earth Day, it's so important to remind ourselves of the ways to protect the planet, and fighting climate change is one of those key issues.
Yeah, researchers at the Salk Institute are doing exactly that. And joining us now to talk about it is Salk professor and Harnessing Plants Initiative Executive Director Wolfgang Busch. Nice to see you. Thank you so much for being here and the work you're doing.
It's a pleasure to be here.
Wonderful.
Thank you.
Talk to us about, I mean, it's Earth Day, so it's a great day to talk about this, but you know, this is a climate change is a problem that we've been talking about for quite some time now. What you guys are doing as far as developing new types of plants, is that right, to try to fight climate change?
That's correct. And, you know, the whole problem with climate change is that we're accumulating a lot of this carbon dioxide in the atmosphere by burning lots of fossil fuels. And so we now know that it's really necessary to pull down some of that CO2 at some point. And so plants are the world champions already. And so we are trying to make them better, to store more carbon for longer in the soil.
So how much could they reduce the carbon by at this point? Like, I mean, because plants, like you said, are natural scrubbers. They can remove that carbon dioxide. With your work, what is it doing now as far as absorption?
Yeah, so plants already do a fantastic job in absorbing many, many more times the carbon dioxide that we actually emit each year. But the thing about this is that plants are really good at catching it. They have evolved billions of years to get really efficient at this, but they are not so good at holding onto it. So what happens every year is that plants draw down like gigantic amounts of carbon dioxide, but lots of it decomposes, like in the fall. The leaves fall on the ground, they decompose. And so the whole way to make them better is to think about how can that carbon that they pull out from the atmosphere, from the air, with the power of sunlight, how can we make it stick around for much longer? And our solution is to think about the roots. So plants take down carbon dioxide, and some of it gets into the roots. Roots grow in the soil, and the soil is already a huge sink, a huge carbon bank. So we want to grow this bank, and we do this by making the roots bigger and deeper and contain a number of natural carbon compounds they already make, but to a higher extent that will stay around for much longer. So that plants catch the carbon dioxide, put it in the ground, and it stays there for a long time. And if you do that at scale, you know, there's so many plants on this planet. There are hundreds of millions of hectares of plants cultivated by the farmers of this earth and this country. If we basically make small changes, that can have a large effect in the area, in the amount of, you know, gigatons, if we roll it out on all the farms and all the land on this earth.
So you're talking about the roots being able to put it into the soil. One, is that bad for us in any way, shape, or form to have it stored down there instead of up there? And how can you take any plant and make it with longer roots, or is it like its own unique kind of plant?
Well, there are some things we know are very conserved, so they work in many different plant species. So by identifying, for instance, one gene that works in one plant, in many cases we can use the same solution in another plant. And then when it comes to the effect, you know, more carbon in the soil is better for us as well, because more carbon in the soil means often a healthier soil.
That's where we want it.
So by storing the carbon in the soil, we're not only going to reduce the problem in the atmosphere with the carbon dioxide, but also makes the soil better and perhaps the plants more resilient to some of the bad changes that will happen with climate change.
So then you're also doing work with coastal plants or wetlands as well. Talk about that.
Yes, so on one hand, and as I was saying, we work with crop plants to engineer and to make the root systems better. And on the other hand, there are other plants that actually can do a lot. In coastal environments and wetland environments, plants already store a lot of carbon. But these wetlands and these coastal areas are endangered by human activity, by the environment. And so we are working on ways on how to see how we can repopulate some of these endangered areas with plants that are fit for the changed environment that exists now.
Wolfgang, before I let you go, what is the timing of this? For example, if we want to try to fight climate change as fast as possible, right? We keep saying, oh, it's going to get out of control. How soon can all of this be implemented around the world?
Well, on one hand, it always takes a while.
Yeah.
We know that if we change plants genetically through breeding or biotechnology, it can still take a decade or more that it actually will be adopted by farms and rolled out, on very large acreages. But we know this already happened. We know that agriculture has an immense capacity to take up new varieties, new updated seeds, and roll it out. So once we have made this transition, it actually can go very fast. And so it will take for longer, but it's faster than any other large-scale CO2 drawdown methods that I know of.
Makes a lot of sense.
Yep.
Incredible work you guys are doing.
It.
Yep. At Salk Institute, Wolfgang Busch, we appreciate your insight, your hard work, and looking forward to seeing how this plays out here in the years to come.
Thank you very much.
Yes,
Thank you.